Hi everyone, welcome back to Education with Eleanor, and now we're in part 3 of the right hand grip rule for magnetic fields. So in this video we're going to look at loops. So we're going to figure out the magnetic field in the loops when they are carrying a current. Now if you like this content, please subscribe and press the thumbs up button. Let's get into it. Alright, so let's have a look at loops. So what's happening here is that we have a loop that's laying flat on a page. So for example, it'll be just flat on the page like this, and the current is going anti-clockwise. We want to determine the direction of the magnetic field in these loops. So let's do part A, or question A, first. So what you're going to do is you're going to pretend that this side of the loop is cut. Imagine you cut a little bit off like this, okay? And we know that if we straightened it out, it would look like a straight line, and then the current is going up the page. So let's get our thumb, okay? And when we get our thumb, it's going to be going up the page, and then we wrap our hands around, okay? Our fingers around. Now, on the left-hand side of the loop, we know that the magnetic field is going out of the page. And then if we keep rotating around, when we get to the right-hand side, the magnetic field is going to go into the page. So to show that, we need to show that the magnetic field on the left-hand side of the wire is coming out of the page. So we draw a dot, write a circle around it, and then to show that on the other side it's coming into the page, we do a cross and draw a circle around it. Now let's keep moving our thumb around. So in this case, at the top of the loop, we know that the current is going towards the left, so my thumb's going to go towards the left, and then we know that we wrap our fingers around. Okay, so underneath the loop, the magnetic field is going to come towards you. So if we keep wrapping around, or try to, my hands can't really wrap around properly like this, but it's going to go around and into the page. That's what my fingers or the magnetic field will do. So once again, on the inside of the loop, we know it's coming out of the page, so we draw the circle, and then to go into the page above the loop, we draw the cross and draw a circle around it. Let's keep going. So on this side of the loop, the left-hand side of the loop, we know that the current is going down. So that's what my thumb is going to do. And then I'm going to wrap my fingers around, and you can see that on the right-hand side here of the loop, it's coming out of the page. So it means that on the left-hand side here, the magnetic field is going to wrap around and it's going to go into the page. So we've got inside the loop is coming out of the page, and outside the loop on the left of it, it's going into the page. So let's look at the bottom of the loop. We know at the bottom of the loop that the current will be going towards the right. So have my thumb going towards the right. Remember, we're using our right hand, and we will wrap our fingers around. So above the loop here, it'll be coming out of the page, and then underneath the loop, it'll keep going around and then go into the page. So inside the loop, it will go out of the page, and outside of the loop, it'll go out of the page. So this is how we show the direction of the magnetic current. Now you can draw more of these field lines like this and fill in the gaps there. Remember, the more dense your field lines, the stronger the field strength that is being implied. Alright, let's go to part B. In part B, we're going to look at this loop that's been rotated into the page. So initially, the current is going anti-clockwise like this, and then we rotate it a little bit. So we're kind of wondering, well, in which direction does the magnetic field go even if we've rotated a loop? Now, as you will notice, in part A, our current, so I'll bring this back up just to show you. Our current in part A is going anti-clockwise. Okay, that's the direction our current is going. And if you notice here in our loops, the current is also going anti-clockwise. So what we can do is that, once again, our field lines, they will be on the inside of the loop, they'll be coming out of the page, and then on the outside of the loop, they'll be going out of the page. Now, another thing that way it can be shown is to draw circles. So, for example, if we do this around here, okay, and at this point here, okay, the magnetic field is coming out of the page. To show it that way, you can show it like this. So you can see that it's coming out of the page and then back into the page. So let's do that again. So I'll draw a loop like this to show the magnetic field, and the magnetic field is coming out of the page inside the loop, and so it'll go into the page on the outside of the loop. And let's do the bottom here. So I'll draw the magnetic field, and on the inside of the loop it's coming out of the page, and then it'll go all the way around back into the page. And we'll do this again. We'll draw another magnetic field here, and on the inside of the loop it's coming out of the page, and then it'll loop back in. So once again, we can draw in more loops if we want to, more magnetic field lines if we want to show a more dense magnetic field. So if we do that like this, so on the inside of the page it's coming inside of the loop, it's coming out of the page. Here we've got that again, on the inside of loops coming out of the page, and we can do that here. So on the inside of loops coming out of the page, and we do that again here, and on the inside of the loops coming out of the page. Okay, and if we want to match them up, we should also do that on the left-hand diagram as well, just so we're matching. Okay, I hope you liked this video on part 3 of the right hand grip rule, and this time around we learned how to figure out the direction of the magnetic field when you have loops. Stay tuned for part 4 and subscribe and hit the notification bell and the thumbs up button if you like this video. Alright, see you for part 4. Bye!